Well, we might rightly ask, this general power rule for integrals right here, could it be applied to any other kind of function? And the answer is most definitely it can. In this particular case, we might not see it as quite so obvious unless we rewrite this integral a certain way. Let's try rewriting this here. We see that we have cosine of x in our expression and a mixture of sine of x. And we might note that in this particular notation, sine to the fourth x is the equivalent of stating it as sine of x raised to the fourth power dx. And now we might think, oh, that's actually kind of familiar. Because if we make a substitution where we make u equal to sine of x, we know that its derivative du is going to be equal to the cosine of x times dx, both of which are present in this expression. And so rewriting this using our general power rule form tells us that we have u raised to the fourth power, replacing sine of x to the fourth power, times du, replacing cosine of x times dx. Now, that's actually very straightforward because now we've got 1/5 times u to the fifth plus the constant, and replacing u results in our actual integral in this case, which is going to be 1/5 sine of x raised to the fifth power plus our constant. But rewriting it and using the notation that we have in our original expression, we should really write this as 1/5 of sine the fifth power of x plus c. And we should see, by the way, that if we were to take our derivative of this by using our chain rule, we will most definitely end up with this expression, cosine of x sine of fourth x, as our derivative.